This video is about oxidation and reduction. The keyword in the question is what the question is asking for. So it's asking for oxidation state of the lead species. And the concept of this question is how to determine oxidation state. So let's look at this equation as an example. And how we can determine oxidation state is to draw out a table like so. So in this table, we have the individual charge and the total charge, and it's divided in columns of the individual species. First, we should ignore the coefficient, so let's cross out all the coefficient. And let's start with determining the charge of the elements that we know. So we know that oxygen has a charge of -2. So let's write that down at -2 in the individual charge for oxygen. And because there is 3 of them, the total charge would be -6. And this whole compound has a total charge of 0, as there is no extra charge written next to the compound. So we know that iron must have the total charge of +6. And the +6 will cancel out the negative charge of the oxygen. And because there are 2 iron element, the individual charge would be +3. We can continue to use this method to work out the rest of the species. And remember, iron, when it's on its own, the charge is always 0. So both of the individual and total charge is 0. And this is how we can determine the oxidation state of each species. Were to go back to the question and looking at this equation, we can do the same thing and draw out a table as we did with the example. And it would look something like this. The question is only asking for lead species, so let's cross out all of the compound that doesn't have lead in it. So now we're only left with the compound with lead species. So lead is on its own, so we know that the individual charge and the total charge is both 0. Here, again, we know that oxygen has the individual charge of -2 and a total charge of -4, and the compound has the overall charge of 0, so lead must be have the charge of +4, and the individual charge of +4 as well. But here we actually have SO4, which is a polyatomic ion. And this polyatomic ion has the total charge of -2. So we know the total charge is -2, and we can ignore the individual charge. And so lead must have the charge of +2, because again, the compound has the overall charge of 0. For the answer, we only need to look at the individual charge. You see that solid lead has the oxidation state of 0. Lead species in the lead oxide compound has the oxidation state of +4, and lead in the lead sulfate compound has the oxidation state of +2. And that's our answer.